Hi friends, welcome back. After looking at one application of linear data structures, the stack, now it is time to see another important application of linear data structure, which is a queue. Yes, you heard it right. Queue, a very commonly used term whenever we are talking about a number of people to be given a service, we want them to maintain a queue. That means whoever has come first for the service will be given the service first. So the concept of queue is first in, first out, or the first come, first served, as opposed to the stack where the one who served first was the one who had come last. So last in, first out, whereas Q is the one which is first in, first out. So Q is a first in, first out, and very commonly used as a buffer in computer system, and very much useful when we are working with scheduling the resources. When the resources are in limited number and the requirement is huge, then we need to schedule them. So while scheduling, the queue comes to our aid. That means when we have multiple processes which want to be executed, but we have only one processor, then the CPU has to be given to each of these processes in an order. So the order should be the one who has requested the service first should be given a chance first. So the first in, first out concept is required there, and to remember what is the way these requests were come. So we do use a data structure called a queue. Same thing, we have limited memory and requirements are unlimited, and again the processors which want to reserve memory for their purpose need to uh, request, and the one which requests first will be given the first chance. So again, same thing. Any process is trying to utilize the memory which is scarce compared to the requirement, then it is to be scheduled again, and this has to be worked in the first come first serve basis. So again, we need a data structure which works in first out logic, and that one is what we call a queue. So whenever a process request for either a CPU or process request for any memory, then it is put on the queue. And whenever a CPU is available or whenever the memory is available, then just look at the queue and see who is the one had asked earlier. So that process will be given a chance to either use the CPU or the memory depending on what type of scheduling we are working on. Other application is in case of nonlinear data structures like trees and graphs, which we are going to see in future. Just to give a idea that what all places we can make use of the data structure queue. Yes, we can make use of queues while working with trees. In case of level or traversal, that means we just want to see who the tree is shown in the different levels, and level wise if we want to traverse, then the queue data structure comes to our aid. Same way, breadth first search, if we are trying to do on a graph, then again queue will be very handy tool for doing this activity. So that's symbolically how a queue can be represented. The queue will have two ends as opposed to one end which was there in the stack. Queue has got two ends. That is the one end where the service is provided and the other end where the one who wants the service joins the queue. So the one who is joining the queue, the process is called NQ, and the one who has given the service is no more will be in the queue, so will be moving out of the queue. So the process of moving out of the queue is called DQ. So DQ is done from the front end or the head of the queue, whereas the NQ operation is done on the other side, which is back end or the tail or the rear of the queue. So there are two ends of the queue, front end and the back end. So the NQ is done or adding to the queue is done at the back end, and the service is provided to the element which is there on the front end. So DQ is done to the front end, NQ is done at the back end. So that's idea how. So if you visualize this as the people standing before a ticket counter, then the process number three is there who has joined before 4, 5, 6, 7, and 8. So in the current situation, if we think that who should be given service first, then it's definitely the person with number 3 will be given service first in this case. And just before this, the person with token number 2 was given service and he is moved out of the queue. And here in the queue there are six people standing with token numbers 3, 4, 5, 6, and 7 respectively. And now a new one is trying to enter the queue. So the new one with the token number 9 NQs and gets position in the end of the queue. So one as the one element gets dequeued, then the front end shifts one step behind, and when a new entry gets into the queue, then the rear shifts one step behind. So this entry one step behind at the head after DQ or one step behind at the back after NQ is performed continuously, and because of this we observe that we start from if you are using a contiguous memory location, and if we are talking about a particular set of memory being used for this queue operation, then we begin with the first location as the first element, then second location for second element, third location for third element, and so on. And then we realize that after some time the first element work is done, so it is no more there in the queue. Therefore the first element position becomes blank. So now our queue start from the second element onwards. So the queue keeps growing on the back side and keeps shrinking from the front side, and this whole thing keeps moving down, 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 and at the end we may reach end of that the whole memory system, and that may be a problem. And we know that usually our requirements are of limited size. Therefore, instead of having a limited memory being used from top and goes move down, 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 and reach end and say that no more possible, though on the upper side we have been releasing the memory, but we are not able to use it because after every DQ we move the front one step down and after every NQ we move the back one step down, so this whole thing keeps moving down, 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 and finally reach the end of the memory. So we may not be able to continue using this, and that's where this circular concept comes into picture. So if we know that we have a limited requirement, then we can make it circular, so that this whole thing keeps moving round and round and round. And anytime, if we have allotted say n locations for the data, and if we are sure that our queue size is not going to be more than n, then we can just keep on shifting the head and tail positions accordingly, and still with only n locations we will be able to work on that. So we were not clear about why the circular list is required, either using array or using a linked list. Yeah, this is one of the reasons. When we are working with a queue, so we move, run out of the memory available, so we can make use of a circular list and can solve that problem. So just as an example, we can see that what we have done is we went on enqueuing and dequeuing. So we created a queue with a enqueue with value 10. So 10 comes in here position. Then we enqueued 8. 8 comes later. Then we said enqueue 12. So 12 comes later. Then we said enqueue 9. 16, then 16 comes, then 9 comes, then 20 comes, then 18 comes, and finally 5 has come. So that's what we have done. So we have enqueued 10, 8, 12, 16, 9, 20, 18, and 5. That's how the data were entered onto the queue. Now, if I start dequeuing, then if when I say just dequeue, then the front element will be removed from the queue. So we get a output as 10, and this 10 no more available in the queue, and the front is shifted to the next location. And next time when we say dequeue, then we get a 8. Next time we get a dequeue, we get a 12. So we just keep on shifting the front, and we keep on releasing these memories. So we start. So 10 was added first. 10 is coming out first. 18 was added last. 18 is coming last. So it is coming in the same sequence. Whatever went in first is coming out first. Therefore, we call this a first in, first out. So looking at the code, the NQ. So NQ is just adding to the rear. So increment the rear and add to that array the new entry. And if you are talking about DQ, it should be removed from the front. So just take out the value which is there at the front, and then increment the front, so that the next time the front will be the next position. So NQ is done at the rear end and DQ is done at the front end. So the same thing we can talk about using a linked list. So we create a node, and then if it is NQ, we add that new node to the rear end, and if it is DQ, then we take out from the front end and remove that node, or free the memory allocated for that particular node. So that's NQ operation, that's DQ operation. So if we can see here, if we say insert 30, then 30 gets added to the end of it, not on the beginning. If it was uh, stack, then we would have said push, or even if we say insert, then 30 would have come in the beginning, not at the end, because it is a queue. The new element added will go at the end. So that's about the what we say application of linear data structure, and that is useful for many programming applications, writing the operating systems using the other applications. Queues and stacks are most important and integral component of any coding activity. So without this linear data structure, it is highly difficult to work more efficiently, both in case of time as well as space. So the linear data structures will help us in reducing the time and space complexities of some of the problems, and it is still unable to reduce the time complexity or space complexity of other type of problems which can be dealt by non-linear type of data structures, which we are going into enter into the new world, the non-linear type of data structures in our coming sessions. So please keep watching. If you find these videos of any use, please don't forget to uh, like and hit the like button, and subscribe, and please share with your friends so that they also can get the benefit out of it. So till then, keep watching. Thank you.